we are happy that the sciences are almost coming to the end. We had maths, followed by biology, then today chemistry, so we are left with physics. But however, we want to say that all subjects are equal, but again the compulsory ones have a lot of weight in your mean grade. So let us be attentive, let us follow the rules of being silent. Those ones who also want to be facilitators, we can give you time, you go and train, and come back and facilitate us. But tentatively, we only have one facilitator and teachers, so that we don't waste time talking. On this other side, the report I'm taking, the network, there is a lot of, I don't know, laziness or what. Can you be attentive? We want to treat everybody equal, and therefore believe that what another can do, another person can do, you can do better. So this side, please, the complaints I get in my office that sometimes you lose it and even fail to be attentive. And when we talk of the mean grade, we are not going to say that the girls on this side or the girls. I think you are sitting in this hall, is it per class? You are a mixed up team, and because you are mixed up, let us not also start thinking that because we are on one side, we can behave differently than others. So up to now, I've said so far so good. I don't want to talk much about chemistry. I've already explained myself to the teacher. We are lucky that we have been having young, energetic teachers who can go for long. And that is why Mr. Buya requested you to go and take a short break so that when you are told we are doing up to 10:30 before we go for break or 11, you don't complain. And again, I was saying that even when you are laughing, like there is a class which always amuses me. Even now, some want to extend the laughter. And I was imagining if you are my daughter or you are my daughters in the house and I have guests. And even a joke has been put across and one of you or your brother or sister is extending the laughter. What do you think what will you imagine about your brother or sister? You always have, when somebody is extending something in a house, everybody has stopped laughing and somebody is extending. Sometimes you start imagining whether kichwa yake ni mzuri. We don't want to go that direction. And imagine in May, I was also imagining you are in college and alumni of Itibo. A small joke in Chuka University when you unataka kucheka mpaka zaidi. I told you you will be in college in May. So we are already training you to behave as an adult while you are there. So some things, can you now start thinking that you are an adult within 2 months? 2 months. Yesterday the ID people came. I don't know whether they have IDs. You are supposed to have taken, is it voter's card? How many of us have IDs here? Yeah. I'm saying that let us not lengthen some of the laughters because what we have is serious business. Otherwise with us, he will introduce himself. I don't want to introduce himself. This is the first time I'm meeting him. But he will tell you what he has done and where he's doing it as he wants to sit here.
Our senior principal, my colleagues, our guests from KICD, and the candidates of the year. God is good.
All the time.
And all the time.
God is good and that is nature. Wow, God is great.
Asante. Today is our day. The day of my subject, chemistry. We want to learn. I'm not presenting. We want to learn. But before we start, I want to say I'm a teacher of chemistry at St. Anthony's Boys High School in Kitale. And many a times I've been to schools, and to be sincere, this is going to be one of the most vibrant classes I've ever facilitated in chemistry. But I want to tell you, because I said it is a subject that you can plan with, we will plan with chemistry, and for sure understand why a student can fail to get grade A. No student is weak in my subject, chemistry. Actually, I did not tell you I'm Martin Amolo. Martin Amolo. And I'm also married, like some of my colleagues here. I'm a very God-fearing man, and we are directed to love our women. And when we love them, there is respect that comes in return. That is what happens with this subject, chemistry. A student who is seated in uniform, if you treat chemistry as your wife. One day I went to State House Girls, and they said, Mwalimu kama ni hivi, then we will marry chemistry. So I want you, so long as you are in uniform, to marry the subject chemistry. Are we together? Yes. You love it. It respects you. You read. You understand. That is it. You only get grade C in chemistry if you want to get grade C. Otherwise, chemistry is love. So Mimi, I just say chemistry forever, and you say chemistry for life. Because that is the truth about chemistry. Chemistry forever.
Chemistry for life.
Chemistry forever.
Chemistry for life.
So chemistry, the subject, is actually tested in 3 papers. We all know. We have paper 1 that will always cut across all the 24 topics in chemistry. Those questions are short structured, each carrying around 3 marks. Cannot be below 3 and should not be above 3. If above 3, then we can have around 2 or 3 in the whole paper. So, we have 24 topics in chemistry, and each question is 3 marks. How many marks are those? 24 by 3. How many? 72, senior. And chemistry is tested out of 80. So where will the 8 come from? Application. Students have tendencies, when we are talking about chemistry of nonmetals, elemental chemistry, nitrogen and its compounds, carbon and its compounds, sulfur, chlorine, etc. And then the very final part of those topics have pollution effect and some other concepts. You like assuming them. They are tested. So let us not assume that. That is chemistry paper 1. Then we have chemistry paper 2, which is also tested out of 80. But we'll test specific skills within a concept. Can test any topic, yes, but there are topics that are dominantly tested, topics that dominate. So that when a student is revising for paper 1, a student is technically revising for paper 2. So that when it reaches a time when you are supposed to prepare for paper 2, you can now focus. And of course, as usual, you don't leave any stone unturned. Then you revise everything, but you concentrate on specific areas, which we will mention. Then the other paper is chemistry paper 3. Chemistry paper 3 is this simple, good ladies. Chemistry paper 3 only tests 2 concepts. One, quantitative analysis, and the other one, qualitative analysis. Chemistry as a subject has around 5 pillars. And when I say pillars, they are concepts that any student at any given time must have at her fingertips, if not your nerves. The first pillar of chemistry is solubility of salts. Pillar number two is periodicity. Just write periodicity. When I say periodicity, I simply mean periodic table and majorly the first 20 elements of the periodic table. Number three is reactivity series. The reactivity series. Number 4, the mole. Just write the molar concept. The molar concept. The truth is, the molar concept only goes around 3 concepts. One is the relationship between moles mass and molar mass. Number 2 are related terminologies like molarity, concentration, and dilution. Does a student know what dilution is? Does a student know what molarity is? And you know the difference between molarity and concentration? Hapo ukijua uko sawa. Then finally is the concept of the mole ratio. The mole ratio. And the last one is organic chemistry. And I'm saying organic chemistry is a pillar because organic chemistry, we are sure, will be tested in paper 1. Organic chemistry will be tested in paper 2. Organic chemistry is tested in paper 3. Therefore, it is a pillar because we come across it in every paper. So, I want to start with qualitative analysis of inorganic. Inorganic. And I want to bring some sense to the mind of a candidate who will be sitting for chemistry in the next 2 weeks. Around 2 weeks. Si ile month ile imepita. Sisi tunaanza next month. And chemistry will be done within the first week, I'm sure. Yes. Paper 1, paper 2, paper 3. Then you can now be somebody you want to be after passing chemistry. So, for a student to make accurate observations and results, you must do the following in qualitative analysis. Number 1, a student must accurately identify the test reagents. That's right, accurately identify the test reagents. Accurately identify the test reagents. I have, ladies, look at this. I have some solutions. This is sodium hydroxide. This is aqueous ammonia. This is lead nitrate. And sometimes we label using chemical formulas. So a student must use sodium hydroxide for sodium hydroxide. Don't use sodium chloride in place of sodium hydroxide. There is a time in KCSE I saw a student in my school. Hata sijui alitoka wapi. Others are getting yellow precipitate. Hii hata kuna yellow precipitate hata mmoja ameona. Unaona mtu akienda kuhit yellow suti. Mwingine akienda kuhit yake inatoka ndio hii ni yellow suti. Wewe ukienda kuhit unasema uliona blue. Wewe usipoona yellow suti, kama hujaona yellow precipitate, ask yourself, how comes mimi sijaona what these people have? It means maybe you confused a reagent. So that is very pregnant. A student must accurately identify a test reagent. Then number 2, identify what these reagents test in qualitative analysis. Identify what these reagents test. Identify what these reagents test. The beauty of chemistry paper 3, our good ladies, is this. Each reagent has got its role. There are reagents that are only used to test for cation, ions. When those reagents are being used, their anions are introduced into the solutions we are testing. There are reagents used to test for anions. When they are being used, their cations are introduced into the solution we are testing. For example, when we are asked to add sodium sulfate solution, we should know sodium sulfate is used to test for cations. So if that is its use, if it is being used, it introduces sulfate ions which are negatively charged to react with our cations present to form a salt. So anytime I use it, I only expect white PPT or no white PPT. If a white PPT is observed, it means an insoluble sulfate has been formed. What do we know about solubility of sulfates? All sulfates are soluble except caliber. All sulfates are soluble except caliber. Sasa, ukiona white PPT, so you will infer caliber present. Calcium ion, lead ion, barium ion. Unaona? Haya, let's say you are using sodium chloride. It is testing cations. You are introducing its anion, which is chloride ions. It reacts na cations present. If you observe a white PPT, insoluble chloride has been formed. You go back to solubility of salts. Then you say all chlorides are soluble except silver. Sasa utainfer lead na silver present. You see how we integrate solubility of salts in qualitative analysis. You see that? So anytime you are using a reagent, you must know what it tests. They are common. They are common, we will mention them. Zico. Another area, another point is that identify the expected observation. Identify the expected observation. Identify the expected observation. Identify the expected observation. So candidates, you are using sodium hydroxide solution. Let's say in the test there above, we have eliminated the colored ions. Then it means colored ions are not present. So that anytime we are using sodium hydroxide, we only expect 3 observations. Either no white precipitate soluble, or white precipitate in. So when you use that sodium hydroxide, you must see one observation you are expecting. In qualitative analysis, a student accurately identifies the reagent, then a student should know what it tests, then a student must expect. The beauty of it, out of what you anticipate, you must see one. That is what you write because you are right. And then finally, accurately perform the experiment. That is a prerequisite. That is a must. Accurately perform the experiment. Ukiambiwa 2 cubic centimeters, it is 2 cubic centimeters. We are now preparing for KCSE. In KCSE, solutions are standard. Solutions, you must take care of the volumes that you are given. If asked to use 1, it is 1. If asked to use 2, it is 2. If asked to use 5, it is 5. You must be obedient. You must obey the instructions. You are asked to, you want to add 7. Then you get a wrong result. Then you say, hiyo mtihani ilikuwa ngumu. Because maybe you added excess and you are not supposed to add excess. You are asked to add dropwise until in excess. You want to add 2 drops, and your excess is 3 drops. And we normally say dropwise can be 2 to 3 drops. What is the meaning of excess? So you must obey. If you are asked to pipette, it must be 25. If you are asked to top up to the mark, it must be to the mark. You must be obedient and perform the experiment. Now, I want to talk about what matters in qualitative of inorganic. Number one, we all know if given a solid, at times students can be asked to describe the appearance. Like last year, students were asked to describe the appearance of the solid. When asked to describe the appearance of the solid, we want you to tell us the color and the texture. When I say texture, powder, crystalline, sasa. Yes, the solid can be a white powder, white crystalline solid, blue crystalline solid, blue powder, and etc. See, you understand the texture between a powder and a crystal. Yes, so you know how to identify crystal. Utaona tu solid. If it is white crystalline, hiyo ndio unaandika. If it is a white powder, hiyo ndio unaandika. Number two, we cannot carry out chemical analysis on solids without making their solutions. So when the solid is soluble in water, we will add water. Right? When the solid is insoluble in water, we must make the solid soluble so that we can have its ions. And in this case, we are going to use dilute nitric acid. Why? Because all nitrates are soluble. Sindio? Yes. Maybe it is a salt of lead. A salt of lead, ukiongeza HCl, lead will not dissolve in that solution because lead chloride is insoluble. So in all cases, we will be using dilute nitric acid. Now, when you are asked to perform an experiment on a solid, then you start by adding water to the solid. What a student must know is the intention of the setter and how examiners mark and what examiners look at. So number one, you must know whether you are using an inorganic compound or an organic compound. Which compound are you analyzing? You know, last year sodium hydroxide was also used in qualitative analysis of organic huko. So what will tell a student that this solid Q is an inorganic compound? You will look at the types of reagents that you are using. You already know reagents used to test for cations and anions. Lazima ujue. Are we together? Yes. When you are analyzing an organic compound, again there are specific reagents that are used in that particular equation. Then you will say that in this case, this solid is an organic compound. Because anytime you are asked to add water to an inorganic, a compound made up of cations and an ion, our marking point is colorless solution. If the solid dissolves, you must say the solid dissolves to form a colorless solution. And if the solid dissolves to form a colorless solution, you normally infer the absence of kofefe, copper, ion, ion 2 ion, ion 3 ion. Unasema nini? Absent. Why are you saying they are absent? They are tied to the color of the solution. Are we together? Yes. So you see, marking point this side, the colorless solution. But the other side, when we are analyzing an organic compound, we are testing for polarity of those organic solids. So it means a polar substance is a substance that can dissolve in water. So the other part we mark, if it was a solid, the marking point is dissolves. You get that? But because we are sharp ladies who knows what to do, anytime a solid dissolves in water to form a colorless solution, whether in organic compound or organic compound, where kazi yako ni kuandika dissolves to form a colorless solution. Huko pia dissolves to form a colorless solution, so that it is our work to look for the point that we want. Huko tuangalie dissolves, huko tuangalie colorless solution. Are we together? Now, when candidates are given a solid mixture, a solid containing a mixture of soluble and insoluble salt, there is an aspect of filtration. In the same question, students are going to use the filtrate. And part B of that question, students are going to use the residue. So if you are just asked to add water, one, you must ensure that you shake thoroughly. You lazima. So even if you are instructed, add 10 centimeters of water to the solid in a boiling tube and shake. Where you must ensure that you shake thoroughly, so that we don't leave some of the cations that was supposed to be in the filtrate present in our residue. Are we together? Yes. After doing that, students normally find hard time in scooping the residue to be used in the other question. You are advised always to rinse the residue. Are we together? Then you dry between filter papers. So my colleagues here will be giving you 2 filter papers, so that after rinsing, again you can dry between the other filter paper. Then you will have a pure residue, because we don't want to make nitty-gritty errors that can cost a student. So tumesema ukiambiwa filter, shake and filter, lazima ushake aje thoroughly. Sasa vizuri kabisa. Then you filter, then ile residue wakati unataka kutumia, you rinse it with water and then you dry between filter papers. We are sure we will get accurate observations. Otherwise, before you start carrying out tests on the filtrate or the residue, a table may be drawn. And then, if there is a table, we want you to tell us the color of the filtrate and the color of the residue. Are we together? Yes. White residue, colorless filtrate. White residue, blue filtrate. Blue residue, colorless filtrate. etc. And now when you are supposed to infer, you infer against. You infer against. You infer against. You know what I mean? What I mean is this. What I mean is this. You have a solid. Then a candidate is asked maybe to hit a solid and test the gas produced. Then a candidate observes a cracking sound. There is only one solid that burns, that when heated produces a cracking sound. Which solid is that? Lead. So maybe you have observed a cracking sound. That is your observation number 1 when you are hitting a solid strongly. Let's say we have a cracking sound. Cracking sound. Nikiandika hivi watu wa nyuma si wanaona? Cracking sound is our observation number 1. Then a colorless gas that puts off a burning splint. Let's say we have those 2 observations. One, cracking sound. Then number 2, a colorless gas that puts off a burning splint. Because you are asked to test the gas produced using a burning splint. It must be burning. Higher. Sasa cracking sound should tell us that it was a compound of lead. So the inference is lead ions present. Then this other side where a colorless gas that puts off a burning splint, the inference should be what? Carbonate ions present. Because if the gas is capable of putting off a burning splint, then we know we have colored gases. Nitrogen oxide, for example, is brown and will put off a burning splint, but our gas was colorless. So colorless gases that can put off burning splints are only 2, hydrogen and CO2. Are we together? The only difference is hydrogen will put it off with a pop sound. It means that it was a carbonate that was producing CO2. So I was saying you infer against this way. Utapata mwanafunzi mwanafunzi anajua inferences against the two observations, anakuja naweka carbonate hapa juu alafu lead hapa chini, you will not score for inferences. Are we together? So kama ni cracking, against your cracking ni lead ion. Kama ni colorless gas that does, against it. That way. That is what I mean. The chemistry of qualitative analysis is about elimination method. You got that point? The chemistry of qualitative analysis is about elimination method. Elimination method. Nikisema elimination, this is what I mean. We have the solid salt, solid Q. Then we carry out chemical analysis on the solid. And our sole aim is to identify them. So when we say elimination method, then I mean any cation or any anion inferred to be absent there above. Nikisema there above, you understand what I mean? Inferred to be absent there above. Ile test ulifanya ya kwanza, ukasema these three ions are absent. Their presence are not supposed to be seen anywhere again. Are we together? That is what we mean by elimination. So it's about elimination. Another one is flame test. Flame test. Flame test will also be used to test for cation. So, yes. Hapo kwa flame test, hata tungechora two table so that we see how cations are tested using flame test. I know we know. When the color is yellow, yellow flame, sodium ion, very good. When purple flame, potassium. I want answers from behind. I want answers from these doctors and nurses and engineers. You know, courses you cannot pursue without my subject. Studio? Yes. Which question did I ask? Pei sasa. Umesahau swali nimeuliza? Then I want Pei and all others to draw such a table. Sasa we want to disapprove. So hapa utaandika observation, hiyo ni flame test. Observation in bracket color of the flame. This is the pen. This is the best. So everybody can see. Alafu hapa ni inference. In bracket cation present. Alafu tunaanza when yellow flame. Do you think you can see yellow and you see white? You only see one. Ukiona yellow unaandika unainfer nini? Sodium. Ion. Sawa? Yes, ukiandika sodium unaanguka. sodium ion present. Kama ni red or najua wengine don't regret huwa inafanana na orange, si ndio? Yes. That is why we also accept orange for calcium. Lakini when I came here, I had a teacher teaching you. And the teacher was telling you that a candidate should not answer using ranges. Sasa? Yes. That is for us. So you are not supposed to give us an option. You only observe one color. Kama ni red, kama ni orange, ni orange. Then what will we infer? Present. Sinivo? Yes. If it is white, magnesium, ion. If purple, I know you will not see lila. You will observe purple. Alafu utasema nini? Potassium ion. Ukiona green, what will we infer? Copper or barium. Copper or barium. I have a simple question. Can you tell me you have an answer? I have a simple question. I have a simple question. If the solution we are dipping the glass rod in was blue in color, and the color of the flame is green, what is our inference? Copper ion. Isn't it? Yes. Beautiful and smart and sharp. Thank you. Yes. If it was a colorless solution, what is our inference when the color of the flame is green? Barium. Isn't it? Very good. There is another one, when it is crimson or scarlet flame, it is lithium. Those are the commonly tested ions using how to understand this concept. A student who has solubility of salts at her finger like this and knows the role of the reagent and what the reagent is introducing to the solution you are testing, you cannot fail even a half a mark in qualitative analysis of inorganic. Bora tu unajua technical areas like wakati nina test the gas using this, what is expected of me. Sio tumesema if I'm using litmus papers, what is expected? So we will give you a complete exam, then see how you will respond to qualitative analysis. Hapo sawa? Yes. Hapo sawa? Yes. After the whole presentation, sawa? Yes. Yes. Sasa qualitative of organic. Hebu tuangalie hapa vizuri. Tukiacha qualitative of inorganic, the question is, if you quit your own time past the day today, can you screen through different questions, ask them from your teachers? Sometimes I can give you observation or I give it utafanya hata dry. Sasa, do you know dry practical? Yes. Yes, utafanya hata dry. So that nikikwambia kwamba that solid sticks up, unajua tu. In qualitative analysis, qualitative analysis of organic. Let us start by writing reagents used. I know we know them. Let us write reagents used. Sasa tutaanza hivi. Reagents used. We are in qualitative analysis of organic compounds. Reagents used, number 1. Reagents for substances. Because you also want to talk of burn. So andika tu hapo burn stroke ignite. Burn stroke ignite. Burn stroke ignite. Burn stroke ignite. Number 2. Ethanol. Ethanol. Number 3. Number 3. Water. Water. Number 4. Number 4. Bromine water. 5. Chlorine water. Chlorine water. 6. Acidified potassium manganate 7. We have said acidified potassium manganate 7. Next is acidified potassium dichromate 6. Acidified potassium dichromate 6. Acidified potassium dichromate 6. Acidified potassium dichromate 6. Yeah, expert uncle. You are safe. Universal indicator paper, stroke universal indicator solution, stroke pH real. Universal indicator paper, stroke universal indicator solution, stroke pH real. Another one. The spelling of pH real is on the board. Small p, capital H, R double E L. Universal indicator paper, stroke universal indicator solution, stroke pH real. Hapo sawa? Good. The other one, sodium carbonate, stroke sodium hydrogen carbonate, stroke any carbonate or hydrogen carbonate. Maliza hiyo. Sodium carbonate, stroke sodium hydrogen carbonate, stroke any carbonate, stroke any hydrogen carbonate. Stroke any hydrogen carbonate. Next, copper 2 oxide. Copper 2 oxide. Copper 2 oxide. Copper 2 oxide. Cork sulfuric 6 acid. Cork sulfuric 6 acid. Cork sulfuric 6 acid. Cork sulfuric 6 acid. question that will capture all the reagents and substances used that is mentioned. So, now the beauty of this particular part, I know here you score highly, right?
Yes.
And that means if tested, you should score everything.
Yes.
Because upon the use of one reagent, you only expect 2 observations. Sasa wewe utaona moja, huwezi ona mbili zote. Sawa? Organic compound can either be a solid or a liquid. Organic compound can either be a solid or a liquid. So when there is an aspect of addition of water, we said so long as it is an organic compound, we are testing for polarity. The marking point is dissolved. It is the solid that will dissolve. If it was a liquid organic compound and we've added water, you must tell us whether the liquids are miscible, forming 1 layer or 2 layers. Of course, if they are not miscible, if they are miscible, then 2 layers will be observed. Now you don't say dissolve. Tumeelewana?
Yes.
We know your chemist may tell you that a solute can be in any state. Sio ni ukweli? A solute can be gaseous, a solute can be solid state, or a solute can be in liquid state. But in this case, we have a liquid talk of miscibility. Tumeelewana? Yes. Haya, when you are supposed to burn, a solid is burnt, but a liquid is ignited. The reason why I'm saying this, I can set a question now. That solid Q is suspected, or liquid Q, let me use liquid. Q is suspected to be a polar unsaturated organic acid. Nasikia swali. Is suspected to be polar unsaturated organic acid. Then I want you to write your own procedures and give me expected observations. Wakati you are writing your own procedure and it is a liquid, it is supposed to be ignited in a watch glass. Are we together? Though, because normally when you ignite in a watch glass, a lot of watch glasses will be broken. Ukipewa hapo, una ignite in a watch glass. Ukipewa spatula and it is a liquid, you ignite in a spatula. Sisi tutawapatia spatula. Tumeelewana? Yes. So, what is important? There are reagents which, when used, a student must mention the original color, the name, and final. Bromine water, chlorine water, which is not commonly used. Chlorine water is not commonly used. But chlorine water is used the same way bromine water is used. What is the color of bromine water, ladies? Yellow. Senior? Yes. Color of chlorine water is now green-yellow. Na zote zitakuwa decolorized. So what I'm saying, bromine water, chlorine water, acidified potassium dichromate 6 and acidified potassium manganate 7. Hizo, when you are using them, tell us the original color, the name and final. Hii ilikuwa rahisi. Sio rahisi. Ama hiyo kizungu ni ngumu sana. Sasa utasema yellow bromine water turns colorless. Purple acidified potassium manganate 7 decolorizes, turns colorless. Orange acidified potassium dichromate 6 turns to green. And I know where students have problems when identifying a color change from orange to green. Very compounds with ROH, because acidified potassium dichromate 6 only tests for ROH. Sindio? Only ROH. What you must know, in qualitative analysis of organic compound, these reagents are independent. Are we together?
Yes.
These reagents are independent. So that even if a student used acidified potassium manganate 7 and it is not decolorized, alafu tena utumie acidified potassium dichromate 6 na it turn green, you are sure ROH is there. Na unajua ROH lazima i-change acidified potassium manganate 7 to colorless. So that should tell you that there is a problem somewhere. In the year 2018, my colleague there can be a witness. There is one school, Marcelo School, when a solid was burned, it was burning with a yellow sooty flame. But anytime when bromine water was added to one of the solution, yellow color was remaining yellow. The question is, bromine water is used to test for unsaturated hydrocarbons. How comes it was burning with a yellow sooty, but now the bromine water is not decolorizing? Around 90% of students fail. But in Marcelo School, those boys were a bit sharp. Wakasema, if it was this yellow sooty, bromine water is supposed to be decolorized because there is unsaturation. Wakaforce yellow bromine water decolorizes. Walipata. So we are testing for the groups of organic compounds that we learned in organic. If you burn, it is either yellow sooty or blue. So when there is another functional unit that can bring about a change in color, then in the inference, the presence of that functional unit must be mentioned. For example, yellow sooty. What is our inference? C, double bond, then you open. C, triple bond, present. Then you open. And don't forget and include H. Do you know the penalty if you include H? Ukisema C, double bond C, alafu uko H. You are now wrong. Because you are telling us that compound can be ethene. And the question is, will propene not burn with a yellow sooty flame? It will. That is why you just leave them open. Are we together? That is a functional group. If blue flame, what we don't mark is the presence of alkanes. Are we together?
Yes.
It is not a penalty. There is no penalty. Because we know alkanes are saturated hydrocarbons. So, if you observe a blue flame, the main inference is ROH present. A student who says alkenes, alkynes are absent will score half a mark. Hapo tumeelewana? Yes, because you are sure unsaturated as you go. But there is a functional group responsible for the blue. That is why wewe ukisema absence of alkenes, alkynes, kama blue flame, unapata tu. Sawa? Yes. Maybe my boys, they know. When blue flame, wataandika ROH present, alafu waandike alkenes, alkynes absent. Because even mwalimu knows at times it depends on the chief examiner. So let us award food for alkenes, alkynes. Let us award a half for alkenes, alkynes. Otherwise, if blue, ROH. If yellow sooty, Do you think you can observe a yellow that is non-sooty? Do you think you can observe a yellow that is non-sooty? We know here we are testing either unsaturation or saturation. Unsaturation is normally as a result of a high carbon to hydrogen ratio. Take an alkane with 2 carbon atoms, C2H6. Ratio of carbon to hydrogen 2 to 6. Using 1 to 3. Yes. Lakini an alkene or an alkyne with 2 carbon atoms, alkyne with 2 carbon atoms is C2H2. That is ratio 1 to 1. So there is a high carbon to hydrogen in unsaturated than saturated. That is what is responsible for the production of soot. Because we all understand what happens in luminous flame. When students are asked to explain why luminous flame is bright yellow in color, alafu tunajua because of insufficient combustion, hot and burnt carbon particles will be formed. When hot, they glow to give the yellow color. When cold, upon cooling, they form the soot. So it means that when there is a high carbon to hydrogen, it is supposed to produce soot. And that is why you can either say yellow sooty, even a student who will say sooty flame will score. Again, what I say, we don't want to teach options. We want to teach what you should write, so that you don't fall in that category of accept, you don't get to try. That's all. So it's either yellow sooty or blue. Yellow sooty or blue. There is a student who once asked, when I was at the Chuni Girls, that mwalimu, at times we come across a liquid that is burning and you can see both yellow and you can see blue. You just look for the most conspicuous color. Are we together? Yes. If it was supposed to produce a blue flame and it has some yellow, then it is contaminated. It must be yellow sooty or blue. Hakuna vile utapata hizo jibu. Haya. When a student is asked to dip, maybe you take a glass rod, not a glass rod, sorry. Glass rod and nichrome wire may be used the other side. So if you are asked to dip or to add universal indicator solution or dip universal indicator paper, si tunajua universal indicator paper vile inakaa? Yes. Your observation is based on the color or on the pH value. Sio tunajua? Yes. Sasa kama pH vile sisi nilisema nikikuja hapa nikiingia hapa mwalimu alikuwa anasema none of you should give us ranges at the temperature of 160 to 180. Wewe unasema moja, wewe ni mwanafunzi. So even pH, kuna mwingine anaona hii color inakaa red, mara it's not red, inafanana na hii ya pili. Wewe chagua 1 pH value. Sasa pH is small p capital A. Sio? Nasema tu pH equals to, sasa kama ni 1 or 2 or 3, wewe utakuwa na moja. Alafu what is your inference? What is your inference? Strongly acidic. Sio? Very good. Kama ni 7, neutral. 8, 9, 10, weakly basic or alkaline. Sinivo? Yes. Alafu huko from 11 mpaka huko ni strongly basic. Tafadhali mtu alisahau, unajua? Right now we know qualitative analysis of inorganic and organic is in our paper. And we keep on reminding ourselves in a daily basis. Some of these concepts students should not forget. Copper 2 oxide may be used in qualitative analysis of organic. I remember there was a year it was used. Don't know whether it is imekaa for some time. Sasa copper 2 oxide, magnesium ribbon, carbonates and hydrogen carbonates in qualitative of organic is used to test for the presence of RCOH, acidity. Hapo tumeelewana? Acid huwa ikireact na copper 2 oxide. What is formed? A copper salt. Si ni kweli? What is the color of copper salt? Presence of copper 2 ions in solution. Blue. Si ndio? Usiseme green. Green is only copper 2 chloride and copper 2 carbon. Copper 2 carbon is insoluble. Sawa? Yes. So you can also see that. Sasa ukiambiwa add all the copper 2 oxide, then you observe a blue solution. That becomes the observation, right? So nasema tu RCOH or H plus ions present. Sinivo. Kama ni magnesium ribbon, reaction between metals and acids produces hydrogen gas coming out of a solution in form of effervescence. Same case to when CO2 is produced and any other gas from solution. So a student will write effervescence. Kama unasahau hiyo, bubbles of a colorless gas. Unasema tu bubbles, hivyo. You'll score. Another one. But mimi sipendi fizzing kwa sababu kuna mtoto ataandika hata fishing, andike fizzling, andike fishing, and you will not score. Sasa hiyo kitu ni effervescence ama bubbles. Usiandike Florence. Sasa yes. RCOH H plus ion present. Wachana na hydroxonium. That is option. Sasa yes, because it is an organic compound. The most pregnant inference is RCOH. A student who knows analyzed an organic compound, and if it is an acidic organic compound, it must be an alkanoic acid. Together? Yes. Which other reagent have we not mentioned? Ethanol. Ethanol can be used in 2 instances in qualitative analysis of organic compounds. Ethanol can be used in 2 instances. One, if the organic solid was not soluble in water, we can dissolve it in ethanol, because organic compounds that are insoluble in water are soluble in organic solvents. Are we together? The other part is when we are talking about esterification reactions. In esterification reactions, we know esters are formed. Esters have which smell? Has which smell? Sweet. No. Sweet, Johnny, wait. Yes, listen, smell. So, yes. So, if you are carrying out analysis on this solution, you are adding ethanol. Then as you follow by addition of coke sulfuric acid, and then warm, you know that is a esterification reaction. Do you all agree?
Yes.
Very good. But because qualitative analysis has the sole aim of identifying what we are testing, if it was ethanoic acid that we are adding to the solution we are testing, lizard smell, we now infer ROH. Is that okay?
Yes.
Yes. So, as we said, organic compounds can either be a solid or a liquid. So you should not be confused. Tumeelewana? Yes. If you have any question, question of organic, just ask now. If you have any question, ask. No question. Senor? Yes. So there being no question, if you have kindly ask, this as an individual. This as an individual. I want to say that I have solid Q. Let us train how to write procedures. All procedures in qualitative analysis of organic compound. Hebu tuone kama tunaweza andika. Polar unsaturated organic acid. Kama kuna maji, what will be the observation? Nimesema polar. Sasa observation itakuwa nini? Dissolve. Si ndio? Yes. Nikiban, what will be the observation? Yellow sooty. Si ndivyo? Hizo ndio expected. Nikiweka universal indicator pepper, you are told it is suspected to be an organic acid. What do you know about organic acids? They are weak acids. Zote. Mineral acids ndio strong acids. We know practically kuna moja hapo very strong acid. Kwa sababu kuna vile during its manufacture iko tuna a lot of H+ ions within the molecule. So leave alone that. Umeambiwa ni organic acid. Utapata pH ya nini? 4, 5 or 6? Or 6, ndio? Sasa nikikwambia, if I give you the reagents, can you write your own procedure? Basi andika. You are provided with substance D. You are provided with substance D. You are provided with substance D, which is suspected to be a polar unsaturated organic acid. Full stop. Using the reagents provided. Using the reagents provided, comma, write consecutive procedures. Write consecutive procedures. Write consecutive procedures to confirm the presence of the solid. 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 Roman 1, sodium hydrogen carbonate. Roman 2, distilled water. Roman 3, acidified potassium manganate 7. Acidified potassium manganate 7. Roman 4, universal indicator pepper. Universal indicator pepper. Universal indicator pepper. Roman 5, source of heat.
Ama wanaweza sema tu Bunsen burner, something like that.
Right, source of heat. Source of heat. Nataka at individual level. I want to see the number of tests. Nataka kuona test zote and you have 5 minutes. So hasten your speed. We are saying it is expected to be what? Polar, unsaturated, organic acid. Nimekupa some agents and substances. I want you to write all procedures. You have 5 minutes to do that. But because we are in a class of many, you are allowed to discuss in group of 2s. That's how. You are allowed to discuss in group of 2s. Normally when you are revising as a group, you assume you are alone. So that what you discuss, deliberations there, are also yours at individual level. So you can discuss in a group of 2s or 3s. Now if it is discussion, then you have 10 minutes. So start with that as we distribute our papers. Before we revise this one, let us remember when we were writing our own procedures in question 2. In qualitative analysis of inorganic compounds. Normally this question is divided into 2 parts. The first part will tell a student what the solid is expected to be, and the student is supposed to write her own procedure and expected observation based on the suspected identity of the solid. Part B will now ask the student to use her procedures, in this case her, to perform the experiment. So if we say the solid is suspected to be lead 2 carbonate, like the question that was tested in cases in 2017, the one we've just done, is suspected to be lead 2 carbonate. Maybe the real identity of that solid is not lead 2 carbonate. So when you are writing your procedure and expected observation, they are all tied to lead 2 carbonate because that is what is guiding you. But now when you will be performing the experiment, you had 3 tables. You had test 1, you had test 2 and you had test 3. In part B, we'll have the first table, we'll have the second table, and we'll have the third table. Test 1 must be performed in the first table. So, test 2, you'll read your procedure, you can perform it, then you observe it in table 2, and you infer accordingly. Same case to test 3, don't confuse. Hapo tumeelewana? In test 1 uliongeza maji, sawa? In this table, usikuje uongeze maji hapa alafu hapa ndio useme ati colorless solution. No. What you did in table 1 is now performed in table 1 of part B. I think that is clear. I think that is clear. Yes. Is that clear? Yes. Is that clear?
Yes.
This question I said when inferring, if you are very keen, there is what we call contradictory ion. Can you remember what I said? Tukatumia example ya Kaleba. Sindio? Tukasema if you cannot remember the 3. Sindio? And you can only remember 2. Infer those 2 so that you don't introduce aroma. Can you remember me saying that? Yes. And we said, an example was this, that we have calcium ion. We have calcium ion, lead ion. Maybe you added sodium sulfate, you can put a white PPT, meaning Kaleba present. Sasa, a student who forgets barrier, na na introduce hapo zinc. Zinc unaona na cancel moja na baki na moja. And we are guided when marking. Award 1 mark for 3. Unaona? Award 2, I want a half for 2. And award 0 for 1. So kama moja tayari imecancel, si umebaki na moja. And I think that also happens in theory. That if a student is asked to state 2, I introduce a wrong one. Sisi we look for the first 2. But the moment you introduce a wrong one, you must be penalized. So Mwalimu was requesting that don't introduce a contradicting ion. Don't introduce a contradictory ion. Because the moment a student has burned and you observe a yellow, sooty flame, then you are supposed to infer. We know this is the presence of alkenes or alkynes. We all know carbon uses all the 4 valence electrons in bonding. So that is why we must open zikuwe 4. Na tukasema ukiongeza hydrogen, that is a penalty. Because now you are telling us it is ethyl. This is how they are supposed to be inferred. This question, if 1 mark, we award a half, and we award a half. But the moment you cannot write the function or unit of the alkyl group, then you introduce another bond here. Wewe utaona utapata kitu. Huwezi pata because that is now contradicting. Contradicting. Right? Yes, so you start 0. Sijui kama tunaelewana? Yes. So let us just try to write what is, so that if you are not sure of the formula of the alkyl, so if you cannot remember the 2 very well, andika hiyo moja. So, otherwise all the 2 spots. Now, when using acidified potassium manganate 7, we know we are testing unsaturated plus ROH. Alkenes, alkynes, ROH break. If purple acidified potassium manganate 7 colorizes. If that question is 1 mark, ROH must be there because that is a different functional group from the other two. So we normally say if you added acidified potassium manganate 7, then purple acidified potassium manganate 7 decolorizes. Utainfaa hizi mbili na uongeze ROH. Sio tunajua? This one is a stand-alone inference. Because of that, if the question was 1 mark, it is an half a mark. Sawa? So ukisahau ROH, uandike hizi mbili, utapata tu half a mark. Otherwise, if you write ROH, now you include any of them, you will score 1 full mark. Is that clear, ladies? Yes. But because we are used to alkenes, alkynes, ROH, siko sawa. Unachapa yote. Because mimi najua hii ukora. It may be too much. Niliwaambia even mwalimu can confirm. My colleague examiner in Patrick can confirm that when students observed no white precipitate, when we added sodium hydroxide, it brought a lot of quarrel in the marking center. Because when you observe no white PPC, it is the first test kumeongeza sodium hydroxide. Students wanajua ni amosopo that is present. Actually, the second test they were supposed to carry out flame test. Na ilikuwa sodium ion because the color of the flame was blue. But there above, a student who inferred amosopo was present did not score. So, but a student who inferred the 5 absent cations scored the 2. Kwa sababu swali ilikuwa 2 marks. So tunasema 5, 2, 4, 1, 3, a half. Below that, 0. So unaona hiyo? And they are saying because the observation is negative. So what I'm saying, let us not leave a stone unturned. Are we together? We have no excuse. I told you I don't believe there is a weak student. If Irui could get an A-, I know that. I know that. So mastering these inferences in qualitative or organic uzuri, utaona tu mbili. Yani you expect two na utaona moja. Hiyo tunaandika na hiko tuna inference yake. So in the question that we have just done, we are writing our own procedure. Tumeambiwa ni polar unsaturated organic acid. Then we have given some reagents. Okay, tuko na, can you read them? 1, sodium hydrogen carbonate, distilled water, acidified potassium manganate 7, universal indicator pepper,
Source of heat.
Source of heat. So, it is a solid. What must come first? What must come first? Burning.
Yes.
So, now you must know the difference between burning and heating. This is a chemical property of organic compounds. In organic chemistry, all organic compounds, they burn in air to form CO2 and water. All organic compounds. Burning means there must be oxygen. You are burning in air. That is to say combustion. Burning a substance in air. Like in heating, you can even heat when the boiling tube is hot. That's how. So I don't want you to use the term heat. I want you to use the term burn. Tunaelewana hapo? And if it is a liquid, we said you do what? You ignite. So the first thing, Heat a half a spatula of the solid. Of course, a portion. Heat a half a spatula of the solid. So that is test 1. Heat a half a spatula of the solid. Then expected observation. Where will you eat? In a spatula. So heat, no, hey, I'm again saying heat. Burn a half spatula of the solid in a spatula. Full stop. What observation will we expect? Kama ni unsaturated. Burns with a yellow sooty flame. Sasa hiyo ndio answer, ndio observation hapa, yellow sooty flame. Maybe I have learned the minds of some students this. They don't know what observation is and what expected observation is. Observation is based on your performance. So, you are performing it and seeing it practically. Expected observation is based on the suspicion of the solid. Our observation must be tied to this property, polar unsaturated organic. Tukisema solid is ability to be two carbonate. Our expected observation is based on that particular solid. Hiyo tu. Lakini sasa ukiperform practically, it may not have all those features. Iko sawa? Iko sawa? Haya, that was test 1. There is a student who is observing solid. As students of Itibo, whether an organic or inorganic compound, and you add water, it must. Lazima uandike dissolve to form a colorless solution. Kwa sababu niliwaambia, in inorganic, colorless solution is the marking point. And that is why you infer absence of color. Kwa sababu color solution is colorless. Inside tuna test polarity, so marking point dissolves. Andika yote dissolve to form a colorless solution so that an examiner can look for what he or she wants. Is that clear? Yes. So, situshaandika hiyo procedure ya kuongeza maji. Alafu hapa expected observation ulishaambiwa ni polar. Sita dissolve. Dissolves to form a colorless solution. Alafu now in table 3 to the first, you must sisi wote tuwapatie procedure hata hii body ni. Sijui. To about 2 cubic centimeters, to about 2 cubic centimeters, come to the first portion. Hiyo ndio mmezoea, si ndio? Yes. So to the first portion, in qualitative analysis of organic compound, we may only have a complication somewhere. So, where we have maybe acidified potassium manganate 7, na tuko na something like bromine water. Because salt is in a test unsaturation. So, yes. But potassium manganate 7 inatupatia unsaturation na ROH. Na inatupatia unsaturation peke yake. Burning, bromine, chlorine water. Hizo ni unsaturated. Kumnanga potassium manganate 7, hiyo ni unsaturated na ROH. Dichromate 6, hiyo ni ROH peke yake. Si ndio? Yes. So you'll find that all other tests are independent. Sasa mwanafunzi mwenye akaanza na sodium hydrogen carbonate, huna shida hapo. Ukianza na acidified potassium manganate 7, hapa hakuna shida. Ukianza na universal indicator, there is no problem. So hapa, test yes are supposed to be consecutive when we have two reagents that are testing the same functional units. Umeelewana? Yes. Si unaona sodium hydrogen carbonate hiyo ni acidity. Na si mnaona hiyo kumnanga kwa hiyo ni unsaturated na ROH. Na hii nyingine pia ni nini? Acidity, si ndio? Yes, acidity is acidity. If we use sodium hydroxide in question 3, we are still testing for acidity. Unaelewana? Lakini the observation of a student must tell us if the solid is dissolving in sodium hydroxide. JCSE last year, students were asked to use sodium hydroxide solution in question 3. Okay, I'm going to add even 5 cubic centimeters or 2 cubic centimeters of sodium hydroxide to the solid. Now, unajua hii ni organic compound because we already know how to identify an organic and an inorganic based on the series of tests that we are performing and on those reagents. So, ukishajua ni organic na kuna sodium hydroxide, the observation is this: dissolves to form. Utaona tu kama ni colorless, unaandika tu colorless solute, lakini unaandika acidic substance. Hapo sawa? Hapo sawa? Ukitumia sodium hydroxide, don't say that sodium hydroxide cannot be used in qualitative of organic. Na wanafunzi walianguka hiyo swali because they did not expect. We are lucky. We are preparing for KCSE and we are being told this. Maybe for the second or for the 20th time. Sasa expected ukitumia hii effervescent. Ama bubble. Tulisema tuachane na options. Naona watoto wengi wanapenda hydroxonium ion. Wengi wanapenda hydroxonium ion sana. Na mimi niliongelea mambo ya pregnant inference. Something pregnant is something important. That's all. Yes. Anytime we are separating 2 or more salts that are all soluble in water but have difference in solubilities, we talk of fractional crystallization. This is what we do practically. The easiest practical is a practical insolubility. Kwa sababu, we can even do it now. One question. Ndio hii swali. What we have is a boiling tube. Then the information there above tells us that we are provided with 4.5 grams of solid A. We want you to determine the solubility of solid A. And what we must all know is the unit of solubility. What is its definition? The maximum mass of a solute required to saturate 100 grams of water at a particular temperature. So solubility is not ability. Solubility is not a process. Ukiulizwa or define, you cannot calculate ability or a process. You can only calculate maximum mass of a solute required to saturate 100 grams of water. So tukiulizwa, what is the solubility of? We are being asked to determine the mass that will saturate 100 grams of water. So the unit is your answer in grams per 100 grams of water. Because after plotting the graph, there are questions which will always come. A question may ask you to determine the solubility at a temperature of 20 degrees Celsius. Alafu unasoma vizuri, maybe hata ni 20. Unaandika 20, unasahau kuongeza unit, utapata 0. In grams per 100 grams of water. So if that is the meaning of solubility, then we can design a formula. Nikitaka tu solubility, lazima ikuwe mass in 100. So 100 must be constant. Then we can say that to calculate solubility, we'll have 100 times mass of what? Solute. Very good. Divide by mass of solvent. Sasa hiyo ndio formula ya calculate solubility. In paper 3, we perform our boiling tube with 10 cubic centimeters of water. We add our solid, which is 4.0 grams. We heat until all the solid dissolves. We allow to cool for crystals to form again. Then we record crystallization temperature. When talking about solubility in practical, we are only testing one factor affecting solubility. It is called temperature. How will temperature affect solubility of a salt? Increase in temperature increases solubility. Are we together?
Yes.
Yes. We have alkanoate salt, like alkanoate salt of calcium, calcium ethanoate, whose temperature and solubility are inversely proportional. Otherwise, all other salts, they are directly proportional. Sasa wewe, kazi yako ni hii. You are going to be given a table. In that table, we have experiment number, we have the volume of water added, we have a column for recording crystallization temperature, then we have a column for calculating solubility. Unaanza by calculating solubility, because you don't need to perform the experiment for you to calculate solubility. Where after doing that, you will see the trend. Then the trend will tell you how the temperature will behave. Hapo tumeelewana? Yes. Let me draw one here. I'm happy everybody can see what we are drawing. I want to draw a simple table how solubility is tested in paper 3. How solubility is tested in paper 3. Iko hivi. Angalia. Angalia. How many columns? We have experiment number. Numbers. Which can be 1, 2, 3, 4. Not necessary. But then we have volume of water added. Alafu tuko hapa na crystallization temperature. Then we have solubility in grams per 100 grams of water. Itibo. Then the information there above, you are provided with 4.5 grams of solid A. Sasa,
Yes.
so tuko na information hapa, you are provided with 4.5 grams of solid what? A. Sasa, so since it is calculation, if you look at a paper testing solubility, like this one here, tuko na volume of water added, we have crystallization temperature, and we have solubility, but there is a space on both ends. At times, a mark is normally allocated for showing, because it was a calculation. Are we together? Yes. So, if volume of water added, we started with 2, then 4, then 5, then 6, 4, 6, 8, and then 10. Tunaanza by calculating this. What is the formula of calculating solubility? 100 times mass. So what is the mass of our solid? 4 point divided by mass of the solvent. At this point, what is the volume of water being added? So what is here? Half. Alafu hapa where we have 6. It will be 100 times 4.5 divided by 6. Hapa where it is 10. It is going to be 100 times 4.5 divided by 10. Sindio? Unaonyesha, you punch in the calc, then you write your answer. So can you punch and then tell us the answer here? When we use 2 cubic centimeters of water. Haraka, answer? 225. Okay? Hapa, when the denominator is 4, 75. Oh, umesema 1?
112.5.
Yeah. Divided by 4 hapa ndio nauliza.
112.5.
Hivyo?
Yes.
Then hapa
75.
75. Alafu hapa
66. 56.25. Alafu hapa 55. Si ndio? 45. Very good. Now look at that. Look at that. Look at that. You have filled your table. In solubility, because it was calculation, we may not penalize for decimal. We mark decimal in the temperature column. But a sharp student must make all her values in the table in a given column to be to same decimal place. Senior? So what will we do to make all of them? The other one is 56.25. So we want to make all these to 2 decimal places. What will we do to the first one?
0.00.
Haya, sasa mtaniambia 0.00 50 00 sio? Hiyo sasa tunasema tumecheza safe. Tumecheza safe? Safe. That a student has learned. It is called a trend. What is the trend of solubility? Is it decreasing or increasing? Increasing, senor? It is decreasing.
Yes.
Very good. If it is decreasing, there is experimental part of it. Senor, yes. Where you are supposed to record your temperatures. Si unaona lazima ufanye ya kwanza. Ukifanya ya kwanza tuseme crystallization temperature was 80. Not 80. Was 60. Then the next one is 50. What is this one telling a student about a trend in temperature? Sasa wewe unaleta kielele yako, ushapata 60, 50, 40, alafu unakuja hapo unapata 42 tena. Is that not madness? Yes. It's madness. Yes. Yani, ukishaona trend, umefanya ya kwanza, umefanya ya pili. I don't encourage you not to do all of them. You're supposed to do all of them. Sometimes it is good to come up with a nice graph. Because when we are marking a mark for accuracy, we only look for the first temperature reading. Hiyo ndio tunaangalia. So lazima ufanye kwa sababu kila mtu is supposed to get 60 or around that. Sio? Yes. Umefanya ya pili kuona B50. But because you calculated solubility, it is a decreasing trend. Temperature should also be decreasing. So I can have 60, 50, 40, 30, 20, 10. Sio? Yes. Then now when I come to drawing of the graph, tumesema showing alafu tunafanya hivyo. Si tumemaliza solubility. Drawing graphs. Solubility graphs are normally smooth curves. Unaona kitu inasumbua mwanafunzi? Wacha niwaambie kitu. Before I move there. When we are talking about reaction rates, we can test several factors affecting the rate of a chemical reaction. Practically, we can have temperature or concentration. So, in most cases, students are asked to plot a graph of 1 over T against. Wewe ukiona 1 over T against, unajua ni straight line. Ukishajua this is now thermochemistry. There are lines of best fit that must be extrapolated. Kama ni solubility, it is a smooth curve. So unajua tu shape ya graph yako, unajua. Before ufanye wewe unajua. Hii ni solubility. Trend decreasing, it must be a smooth curve. Na lazima ikuwe smooth. Something smooth, you join with a free hand. Kwanza hapo, wasichana wanajua vizuri. Very accurate. So let's say that you have a graph like this. this one? Yes. That is why we normally propose a frequency. That's all. So there is something at a sharp pencil and there's something very smooth. Wacha nikwambie, when it is smooth, ask mwalimu. Unapewa tu tatu, so long as scale iko sawa. Ukishaona this is a smooth curve and you have not inverted your table, your graph, you'll get all the marks. So long as you plotted correctly. What you must not do is this. Solubility graph si lazima uextend ikuje origin. Unaelewana? Yes. You only extend ikuje origin if the shape of the curve will be maintained. But if it will not be maintained, tuseme imeanza hapa. Imeanza hapa. Ilianza hapa. Hivi. Utaforce ikuje hapa. That will now be a wave. That is something similar to a wave. So for solubility, you can leave it suspended the way it is. You'll stop the math. Kitu muhimu, mwanafunzi apate graph level uko na half. Yani kusema tu solubility in bracket grams per 100 grams of water. Temperature in degrees Celsius uko na half. Alafu choose the right scale. Sisi tunasema hivi. Graphs that you are going to be given, in most cases they are squares. Hesabu on x-axis 1, 2, 3, 4, 10. Y-axis 1, 2, 3, 4, 10. Values plotted should cover a half or more of the graph. Sasa, a half or more of the graph. Sasa, so 5x, 5y. Kama ilikuwa 10. Kama ilikuwa 20. 10x, 10y, 10y. Uko na scale. Alafu unachora curve. Kwa sababu after plotting, you will plot correctly, utapata P1. Sasa C1 utashindwa kama ni smooth curve. Utapata. That is why I was saying before you start practical, you have 25 marks. You uko na 3 marks ya graph. Na uko na 11 za table. Na uko na observation. You have 25. That is called solubility. Is that okay?
Yes.
Is that okay?
Yes.
I want to teach reaction rates before I talk about the practical approach. Allow me to teach reaction rates. Because reaction rates we can teach in 20 minutes. There is a year students who are asked, define it of reaction. Hiyo ilikuwa rahisi sana. But students were not scoring. There was a time they were asked, what is a reaction rate? Or what is a rate of a reaction? What is it of reaction? The heat energy that occurs, or the enthalpy change that occurs during a chemical reaction. See the unit of reaction. Yes, the exchange that occurs during a chemical reaction. The unit of reaction. So reaction rate is a measure of how much products are used up or consumed, and how reactants, sorry. A measure of how much reactants are consumed or used and how much products are formed per unit time. Use lazima ikue per unit time. Per unit time. A measure of how much reactants are consumed and how much or many products are formed per unit time. Per unit time. That's the only marking point. So it means, for us to say that A and B has reacted, we must measure time. Studio?
Yes.
When is the reaction said to be faster? When the time taken is short? Shorter. Do we agree?
Yes.
Yes. So if time taken is longer, the reaction rate will change. But when the time taken is shorter, it has taken place at a faster rate. Before we talk about reaction rate, for a student to understand that concept, a student must know the meaning of collision theory and activation energy. If A is to react with B, particles in A and particles in B must collide. Are we together? Yes. Yes. But not all collision result in the formation of a product. Collisions that result in the formation of a product are called successful collision. So the minimum amount of energy required for successful collision, is also activation energy. So we can able to represent energy level diagram to show an activated reaction and a reaction that is not activated. And a reaction that is not activated. Don't sleep here. Are we updated? Are we updated up to that point? Yes. So we only have two factors. We have many other factors affecting the rate of a chemical reaction.
I want to write an equation and then we will use it to justify what redox reaction is. Of course, what you must know that all displacement reactions will involve both oxidation and reduction and therefore redox. Zinc, again I use the same. Now zinc reacting with copper 2 sulfate. Let us all observe this because this is a very important topic, as I said. Zinc, if we write the ionic equation for this reaction, when writing ionic equation, all substances in S, Lg are left the way they are, but substances in aqueous state can have their ions separated. Like now, this is aqueous and this is aqueous. We can separate so that we have zinc solid plus copper ions. Then we also have sulfate ions. We'll form zinc 2 ions stroke sulfate ions. Then plus copper solid. That is just a procedure of writing an ionic equation. We then look for ions that are found on both reactant and product side. We call them spectator ions. They cancel out. You can all see we only have sulfate. The ions are all in aqueous state. So it's the same as zinc because it is zinc solid and the other one is zinc ion. So that we have an ionic equation as zinc solid plus copper 2 ions. Then we form zinc ions plus copper solid. I want us to now consider the change in oxidation states. There are rules that should govern a student when assigning oxidation states to elements in compounds or elements in their free elemental state. We believe the oxidation number of any element in its free elemental state, when I say that, sodium as a metal, zinc as a metal, those non-metals, the way they exist, chlorine gas, etc., their oxidation number is 0. But when we have an ion, then the oxidation number is in the charge of the ion. When we have a radical, radicals being groups of atoms with net charge and react as a unit, the sum of the oxidation numbers of constituent elements in a radical is equivalent to the charge on that radical. For compounds, the sum of oxidation numbers of constituent elements in a compound should be equal to 0. We are saying that because a student can be asked to calculate oxidation number in a compound. We have also seen questions asking students even the oxidation number of one element in a compound. For example, if I ask the oxidation number of sulfur in sulfuric 6 acid, then what is the oxidation number of sulfur? What is the oxidation number of sulfur? You are saying positive 6. So what is the electron configuration of sulfur in sulfuric 6? You hear that? You must get the oxidation number of sulfur in sulfuric 6, and because you know sulfur to have atomic number 16, meaning electron configuration of 286, in sulfuric 6 the oxidation number is positive 6, meaning it lost 6 electrons. So the electron configuration remains 28. So, in sulfuric 4, the oxidation number is positive 4. It lost 4 electrons. So electron configuration from 286 becomes 282. Hapo sawa? Good. Now, the oxidation number of zinc is 0. But here the oxidation number is positive 2. We can all see that. Here it's positive 2 and here it is 0. So the oxidation number of copper in copper 2 sulfate is changing from positive 2 to 0. Positive 2 to 0 is a decrease or an increase? A decrease. Meaning the oxidation number is decreasing. So decrease in oxidation number is reduction. So the process that this copper is undergoing is called reduction. Now because it is reduced, this other one is undergoing oxidation. So because this one has been oxidized, it must have reduced the other one. We call it a reducing agent. Then this one oxidized this one. It is now called an oxidizing agent. When we know that concept, we want to apply. But before we apply, because zinc has undergone oxidation, and we are saying oxidation involves loss of electrons, we can write a half reaction for zinc and a half reaction for copper ions. So the half reaction for zinc, we have zinc solid changing to zinc ions and of course losing 2 electrons. Then we have a reaction for copper from copper ions. It may undergo reduction, so in a gain electron. So ukiona gain plus, ukiona loss arrow, plus 2 electrons, what we form is copper solid. These are the 2 half reactions for the ionic equation for the reaction that we have drawn here. What a candidate must now know is this. When a metal rod is dipped into a solution containing its ions, it goes into that solution. If you place zinc rod in zinc 2 sulfate solution, if you place copper rod in copper 2 sulfate solution, those rods will go into that solution. If that happens, going into solution means losing electrons. Electrons being negatively charged, they develop on the rod. And because the solution has positively charged ions of the metal, the solution is positive. Then we have electrons building up on the surface of the rod. That means a potential difference must be created between the negatively charged electrons and the positively charged ions. That potential difference can be represented by a single diagonal line. So like if we dip a rod of zinc in a solution containing its ion, zinc solid will go into solution to form zinc ions. That constitutes a half cell which can be drawn. So if we connect two half cells, we come up with what we call an electrochemical cell. When a student is drawing an electrochemical cell, we have a rule of convention. And a rule of convention tells us that the half cell of a stronger reducing agent. So if we have a half cell of zinc and copper, which one is a stronger reducing agent? Zinc. It must be on the left hand side. Hiyo ni compulsory. Then that of copper is on the right hand side. We come up with what we call an electrochemical cell. So if you are connecting a half cell of one metal and a half cell of any gas, then that gas, it must have a wire connected to the platinum. But now, the platinum has two roles. One, it provides a large surface area over which the gas dissolves to form the ions. That is one role of platinum electrode when you use it for a metal half cell. Number two, it serves as inert electrode. Itibo. It serves as inert electrode. So if, for example, we are comparing a half cell of zinc and a half cell of hydrogen, then what I'm saying is this. Hydrogen is a gas. So when it is a gas, then this is the format. So we must have platinum rod, and then this is what we connect to the voltmeter. So hii inaitwa platinum, but what comes in here is called hydrogen gas. Inakuja ina dissolve because it provides a large surface area over which it dissolves. Then now what we have here will be hydrogen ion. Those standard conditions, we know the concentration of 1 molar, room temperature. It is a temperature of 25 degrees Celsius and a pressure of 1 atmosphere. Sasa, if we were connecting a half cell of hydrogen and copper, between hydrogen and copper, which one is more reactive than the other one? If you can remember the reactivity series, hydrogen comes before copper. It means hydrogen will have a greater tendency to lose. So hydrogen half cell kama hii lazima ikuwe on the left hand side, lakini sasa this inlet ina face the other side. Tumeelewana? And then copper sasa itakuwa on the right hand side. Students can be asked to write a cell notation or cell representation or cell diagram. When asked to write a cell representation or a cell notation, we have two half cells. One being oxidized, the other one being reduced. So one that is being oxidized must still be on the left hand side. One that is being reduced must be on the right hand side. So kama ilikuwa zinc na copper, tunajua zinc is being oxidized to zinc ions. Alafu, there is another half cell of copper which is being reduced to copper solid. Then the two half cells are now connected with a salt bridge. And then you write the state symbols. Then you will score all the marks. Was that clear?
Yes.
Good. Now, because we've said when different half cells were connected to a standard one, we came up with the E0 values. When we want you to use E0 values, we will be using letters. We may not use elements. But you people, you should remember the electrochemical series. electrochemical series is almost similar to the reactivity series, but they are not the same. Are we together? So we can still apply. If we have sodium, and then we have zinc, in the reactivity series, which one is above the other one? Sodium. Therefore, in the electrochemical series, which one should be above the other one? Sodium. So when we have the electrochemical series using the letters which are not the actual symbols of the element, a student is supposed to use the E-note values. When I say that, I have a very simple example. I have element Q plus 2 electrons to form Q solid. The E-note value of this element is negative 0.76. Then I have element X plus 1 electron to form X solid. The E-note value is negative 2.96. Then I have element V, which is a gas gaining electrons to form V negative. Let me say V positive in this case. Then it is positive 0.00 V. I want us to screen what I'm writing on the board, because we are saying it is a concept that a standard paper should not fail to test. Then, if we have W plus 2E to form W negative, then we have positive 2.87. And then we have P gaining 2 electrons to form P solid. Then this is positive 0.34. The E-note values you all see here can serve 3 roles. 1, we can use them to identify the strongest reducing and the strongest oxidizing agent. So, what do we look for when we want a stronger reducing agent? The one with the most negative E-note value. Yes. So, given those negative E-note values, those are reducing properties. Given positive E-note values, those are oxidizing properties. But when I have a metal like sodium and zinc, sodium will have a greater tendency of losing, meaning it will be a reducing agent. In turn, zinc becomes oxidizing agent in that case. So the strongest reducing agent is also the weakest oxidizing agent. The strongest oxidizing agent is also the weakest reducing agent. We can test any. So the one with the most negative E-note value is the strongest reducing agent. And now if you are asked to identify the strongest reducing agent, what will be your answer candidates? X. Now, will you say X ion or X solid? X. Some people are saying X ion, some people are saying X solid. Majority of you are saying X solid. Senior? Yes. Yeah, now you look at it this way. If this is a half cell of a stronger reducing agent because it has a higher negative, the highest negative E-note value, then when it will be oxidized, is it supposed to be oxidized from V solid, from X solid to X ion, or X ion to X solid?
X ion to X solid.
Sasa X ion to X solid, itakuwa positive 1, itakuwa 0. Is that oxidation or reduction?
Reduction.
But it is a reducing agent, meaning it will be oxidized. So it can be oxidized from 0 to positive 1. So the oxidizing agent is X solid. Now the reducing agent. Have I confused somebody? I should not confuse you. I'm saying it is this is a half cell of the strongest. Sometimes a question can ask you to write a half cell of the strongest reducing agent. Kama ni hivyo, unachukua the whole equation. Sasa, sometimes a question asks you, identify the E-naught value of the strongest reducing agent. Unachukua E-naught value negative 2.96. When a question asks you, identify the strongest reducing. Sasa unachukua X solid. Utachukua X ion. Because when it will be oxidized, it can be oxidized from 0 to positive 1. And then we call it a reducing agent. So the answer is X solid. Now, the strongest oxidizing agent is the one with the most positive E-naught value. And what is the answer? Is it W ion or W2 gas? Oxidizing agent will be reduced instead. So, identify the one that is used as a standard electrode potential for reference. V what? V2 gas. Yes. Or it also represents hydrogen half cell. Sometimes you are asked, identify a half cell. Okay, identify element V. Unaweza to identify element V. Hapo unasema answer ni nini?
Hydrogen.
Nasema tu hydrogen. Sawa. Reason inabaki hiyo, it has an E-naught value of 0.00 V. Sawa. That is the first role of those reduction potentials. The second role of reduction potentials is to predict whether a reaction can occur or not. In a case where a candidate is given two half cells and that candidate is given the E-naught values of those two half cells, then you are asked, will the reaction above occur or not? For example, I want to ask a question. Will the reaction between Q solid and X ion occur or not? Angalia tu. Q ion and X solid. Will that reaction occur or not? You know that translates to this application question. Can you store a solution of X in a container made of Q? Angalia vizuri. Do you think you will store a solution made of X in a container of Q? It means at that particular instant, what is in ion state is Q. We maintain that equation the way it is. So then this other one is a container made of Q. The other one is X, Then the other one is a container that is made of Q. You interchange that, and that sign changes. So if you add positive 0.76 to negative 2.96, the answer becomes negative something. That means the reaction will not occur. That means we can store. So, I will pardon that. I have given you these two half cells, including E-naught value. So if I ask if you can store something in a container made of something, I want you to start by calculating the E-naught value made by those two cells. And then if the E-naught value is positive, a reaction occurs. That means you cannot store. If it is negative, a reaction will not occur, meaning you can store. Hapo iko sawa? Sasa I have a solution of Q ion stored in a container made of Q. So naona Q ion is maintained in the equation. Inabaki vile iko, sawa? Then container made of S. Inamaanisha hii S ndio lazima tu change equation yake. Hii X. So tukichange equation, this becomes positive. So ukichukua positive 2.96 plus negative 0.76, the answer has a positive E naught value. That means a reaction will occur. You cannot store. So solution of Q in a container of X, no, the reaction will occur because the E naught value is positive. A solution of Q in a of X in a container of Q, yes, the E naught value is negative. You can store. Hapo tumeelewana? That is another role of the standard reduction potentials. So we've said one, you can predict whether a reaction can occur. You can calculate the EMF of a cell. You can also use them to identify the strongest oxidizing and strongest reducing. And we have not forgotten to say that strongest reducing is also weakest oxidizing. So that ukiulizwa identify the weakest oxidizing, ujue ya kwamba unatafuta the strongest reducing. We should not confuse concepts. I want to talk about electrolysis. Sawa? Yes. Sasa ukishajua hivi and you want to draw half cells. Unataka kuchora half cell ya Q na X. Unaangalia hizi. Which one is a stronger reducing? X. So yake lazima ikuwe on the left hand. Alafu you use those letters because they are not the actual symbols of the elements. In electrolysis, in Form 2, we only discussed electrolysis of molten compounds. Molten compounds are normally binary electrolytes. A binary electrolyte is the one with one type of cation and one type of anion. You're the binary electrolyte. Tumekubaliana? So if you are electrolyzing a molten compound, then the compound itself ionizes to the way it is. Molten sodium chloride. Hiyo electrolyte iko tu na sodium ion na chloride ion kwa sababu ni binary electrolyte. Molten means you just heated, ika change to a liquid. So, you did not add water. Ladies, that is different from adding water to a compound so that you talk of an aqueous compound. Let us not confuse electrolysis of a molten compound and electrolysis of an aqueous compound. For molten compounds, the compound ionizes into two ions only. So that the positively charged ions is normally called cations. Si positively charged ion inaitwa cation. Itaenda kwa negatively charged electron which is called cathode. Sasa that is why we call it cathode. It is called cathode because cat. Yani cat inaenda cat. Cat. An. That clear? Anions inaenda anode, cations inaenda cathode. Sawa? Positively charged inaenda negatively charged electron. What a student must know is this. What happens at each electron? Because we want to practice how to write an equation. We have anode, we have cathode, we have anode. Cathode is the negatively charged electron. We must know what happens there. Electrons are gained or lost. Electrons are gained here. Very good. Gaining of electron is what we call reduction or oxidation. gaining of electrons is what we call reduction or oxidation.
Reduction.
That is where you will not get it right. So, because we started with the differences between oxidation and reduction. Oxidation process involves loss of what?
Electrons.
And reduction involves gain of what?
Electrons.
Sasa tuko sawa, si ndio? I was trying to confuse somebody who did not understand why they were saying reduction. So that we all understand that we started from the difference. So if gaining of electrons occurs here, we can also say reduction. Loss of electrons will therefore occur here, we talk of oxidation. So what happens here is reduction, alafu hapa oxidation. In simple terms, gain, loss of electrons, alafu hapa ni gain of electrons. So for a molten compound, ikienda, let's say we were electrolyzing molten sodium chloride. This compound, it's molten. It has only two ions. Sodium inaenda cathode, a sodium ion. Here, electrons are gained. So ukiona tu gain plus. Hapa chloride inaenda. Lakini what happens? Loss. Ukiona loss arrow, gain plus, loss arrow. So loss, ukishaandika tu formula ya ion yenye iko hapo, kitu yenye inafanyika hapo ni loss, unaweka tu arrow immediately. Kitu yenye inafanyika hapo ni gain, unaweka plus. And what are lost or gained are only electrons. So wewe kazi yako ni kuangalia ita lose one electron to form sodium. Sindio? Now the question is, what will be the state symbols? Because if you write wrong state symbols, you will not score a full mark. You will be penalized a half a mark. When it is molten, it is in liquid state. So, if the ion was in liquid state, then it is discharged as a solid. Is that clear? Yes. This one, the ion is in liquid state, then discharged as a gas. So we'll form up a chlorine gas plus 2 moles of electron. You know we must balance this. Kama ni 2 moles of electron, we balance. What I want you to do is this, or what I want you to know is this. When you are writing equations at anode and equations at cathode, you simplify. Sawa? I know kuna wengine wanasema kwa sababu 2 electrons are gained, then this other side we have to balance by putting 2, 2, 2. 2, 2, 2. We treat it as an equation. We simplify. Tuko sawa? So unaandika tu hivi vile iko, you score all the marks. For aqueous compounds have water. So that when the compound itself is ionizing, water will also ionize. Water ionize, we have hydrogen ions and hydroxide ions. So assuming this was aqueous sodium chloride. So when sodium chloride ionizes to sodium ion and chloride ion, water will also ionize because it has water to hydrogen ion and hydroxide what? Ions. So that finally we have a total of 4 ions. Positively charged, cut. Zinaenda cut. So which ions will go to the cathode? Sodium and hydrogen. Sasa mimi nataka kuuliza. If A is more reactive than B, it means A has a greater tendency of losing electrons. Yes. That means B will have a greater tendency of gaining than A. Sasa sodium and hydrogen zimeenda cathode where electrons are gained. So between sodium and hydrogen, even without using electrochemical series, reactivity series, which one is more reactive? It means sodium has a greater tendency of losing electron. That means hydrogen has a greater tendency of gaining. And what happens at cathode? Electrons are gained. So the one with a greater tendency of gaining is discharged in preference to the other one. That is what we call preferential discharge. We together?
Yes.
Sasa, we had aqueous sodium chloride. Sodium imeenda cathode na hydrogen. Tuko na sodium, tuko na hydrogen. Electrons are gained. Hydrogen has a greater tendency of gaining than sodium. So hydrogen are discharged. Zina gain electrons hapa to form hydrogen gas. So this is 2 and that is 2. So we are balancing this hydrogen, H2 gas, so we must balance this. And when we do this, then the charge must be balanced. Tumeelewana hapo? Alafu hydroxide and chloride will go to the anode. There are 3 anions whose inert values a student must know at her fingertips. The inert value of hydroxide ion is positive 0.40 V. That of sulfate is positive 2.01 V. And the other one for chloride is positive 1.36 V. Tumeelewa hiyo? Sasa kwa sababu we said we can use inert values to identify the strongest oxidizing and strongest reducing. So the one with that is more negative is a stronger reducing. Do we agree? Yes. So kama tuko na positives mbili, moja ni positive 1, the other one is positive 2. Which one is closer to negative? Which one is closer to negative? Positive 1. Sinivo. Sasa if positive 1 is closer to negative, it means lower positives have greater tendencies of losing electrons than higher positives. Do we agree that? Sasa OH iko na positive 4, 0.4. Na hii iko na positive 1.36. This is lower positive. It has a greater tendency of losing. Kwa sababu iko na greater tendency again. But what happens here? Electrons are low. So which ions are discharged? Hydroxide ions. Anytime hydroxide ions are discharged, we form water, we form oxygen, and we form 4 moles of electron. Then we balance by putting 4 and then 2 there. That equation is balanced. I don't know if that was clear. I don't know if that was clear. Now, let us compare the volumes of the gases produced at respective electrodes. Between the volume of hydrogen, tuangalie, how many moles or how many volume, because you know what Gay-Lussac's law is. Senor? Yes. If we talk of Gay-Lussac, we can convert mole ratios to volume rate. So we can say, in this one, 2 moles of electrons are producing 1 volume of hydrogen. Hapa, 4 moles of electrons are producing 1 mole of oxygen. So to produce 1 volume of oxygen, 4 mole of electrons are required. To produce 1 volume of hydrogen is only 2. Meaning that if 4 electrons were lost and they were gained, we will have 4 here. So 4 moles of electron will produce how many volumes of hydrogen? 2. Senor? Therefore, the hydrogen gas produced is twice the oxygen gas produced. If a student is asked to explain why, you simply say, to produce 1 volume of hydrogen gas, 2 moles of electrons are used. While to produce 1 volume of oxygen gas, 4 moles of electrons are. Sawa.